Okay, great. So I'll just start writing from here, then send the PDF and then the same lecture notes to you. Okay, so we have a random sample from a multivariate norm with parameters mu and variance sigma. Let me just try to admit someone again. Okay, so we have yes. Okay, sorry about that. Okay, so now we've you already did this the sample variance x bar. We know that it's just 1 over n sum of the xi's and the covariance. So this we already know. We've done this before from earlier, and we know the following holds. Also, this is what you have done already. So you know that X bar is an unbiased estimator of mu. And we know that also.
Are you writing something?
Yes. You can see what I'm writing.
No, I can't.
How about the others? Anyone else who can see? I think maybe your network may be a little bit slow, probably. Because I'm using 2 gadgets here and I'm able to see on the other gadget.
Oh, okay.
Yes. Tune, you can't see even now?
No, I can't see. So let me maybe try to rejoin.
Okay, great. S is an unbiased estimator of sigma. This, you know, and you can probably verify. I think it's something that has been shown in our notes before. And that the variance of x bar is 1 over n sigma. So this is also similar to the univariate case. Also, it's you can easily imagine using the univariate case. Okay. Okay, so now we can talk about the Wishart distribution. So this Wishart distribution is not in a very nice form. So we won't actually. Okay, maybe just for the sake of it. Okay, so the Wishart distribution. Just try to. It's in a very complicated form, so usually we don't deal with it much. So as you can see, it's not in a nice form. So we usually don't say much about it. It's in a complicated form. Okay, let me just try and admit someone again. Okay, so that's the form of the Wishart distribution. So as you've seen, it's difficult to talk about it much because of its form. Okay, so this Wishart distribution is the generalization of a chi-square distribution. So it's the generalization of the chi-square distribution. So if we have the independent random variable is normally distributed random variable. So please for those joining late, do your best to join in good time because it's a bit disturbing to stop, admit people, and continue. Okay, so we have these z's which are independent and all multivariate normally distributed with mean 0 and the covariance matrix sigma. So then so the Wechsler distribution, it's equal in distribution with the sum of products of the z's. The sum of product of each z with its transpose. So if you are looking at a univariate, in the univariate case, it will just be something like this: zj squared in univariate form. And this, you know that it is chi-square. But since these are multivariate, they are not squared, so you just multiply it with its transpose. Okay. So this is just another way you can at least think of the Wechsler distribution instead of thinking of it in the form of that density I gave above. So this is much more easy to visualize. Okay. So the sampling distribution of the sample mean and the sample covariance. So most of these you can always think about them using the univariate case, then it will be easy to generalize. So since the x is multivariate normal, so even x bar will be multivariate normal. So the only difference will be their covariance. So in this case, the covariance is divided by n. Just like if you are thinking of the univariate case, you have n mu sigma squared over n for the univariate case. So it's just similar to the multivariate case. Okay. So now we can try and get the distribution of S. So you can't think of doing something more advanced or complicated if you can't do the simple case. So we think of it first in the univariate case, then you can generalize from the univariate one, because if you understand it in one dimension, then you easily see in a higher dimension. So that's why we just intend to do in the simplest dimension, which is one dimension. So if we can do it in that case, then one can easily generalize. So I don't know if people are joining or they are kicked out. Okay, so we have a random sample from a normal distribution population. So we have parameters mu and sigma squared. So now from this we know that each y is normally distributed with the same parameters, and y bar also will be normal distributed parameters mu and variance sigma squared over n. This at least you can easily calculate the variance of y bar. In the simple case, it's easy to show. Okay, so now we have our s squared be this is the sample variance. So we have S, the sample variance. So now we want to show that this has a chi-square distribution. So we want to show that it's a chi-square random variables with n minus 1 degrees of freedom. So now we want to simplify the summation.
Guys, am I the only one who's not seeing anything here?
The sir has left.
Does this mean that class is over?
I think his network is just bad.
We just cancel it, can't. Oh.
Right, yeah.